Hello, this video is for Stat 210, Handout 9, Part D, and will include pages 29 through 34. All right, let's go ahead and get started. Part D is going to be talking about the detection of outliers. And we will be working with the uninsured rate, the percent uninsured, in our U.S. counties demographics data set. And here I will be just looking at the state of Texas again. So this is a follow-up or continuation of Part C, where we looked at Texas in detail as well. So here I have just the state of Texas, the 254 counties inside Texas. We can create a box plot like we did show you that. Graph builder, percent uninsured. And then I can just select the box plot again up here. And that'll be the box plot that we'll be looking at here. It does have some outliers identified. We talked about that a little bit in Part C, and we'll pick up where we left off with that as well. So there are two ways to identify outliers. The first is through the use of box plots. It's kind of a visual approach. And what we're looking for is just observations that sit below the lower whisker or above the upper whisker. So those observations there would be considered outliers. The second then is to use a Z-score or a standardized score. And that is based on a formula. So this Part D really just talks mostly about those Z-scores. Again, you can, in Jump, obtain the list of the outliers real easily by just highlighting these and then going underneath tables, subset, and pulling those out. I'm not going to show you that because I showed you how to do that on Part C. So the Z-scores. Let's talk about the Z-scores or the standardized scores. They are again used to identify whether or not an observation is an outlier. These Z-scores assume that the distribution that you're working with is fairly symmetric. And this Z-score uses the mean and standard deviations in its calculation. So if you have one caveat about using the Z-score is that it's trying to identify the outliers, but the mean and the standard deviation can be messed up by the outliers. So we're kind of in a catch-22 here. All right, so there are other methods that can be used to identify outliers, but Z-scores are by far the most common approach. Now that we know kind of what can happen to the mean and standard deviation with outliers, you know that that might actually have an impact on how I calculate my Z-score. All right, so what's just the big idea or concept of a Z-score? Let's just suppose that I have a student who's making $22.50 an hour. So they got a really nice job, $22.50 an hour. A typical student makes about $12.50 an hour. So my question is this student an outlier? This student right here is making $10 more an hour than a typical student, but does that mean that that student is an outlier? And the answer to that is it depends. If everybody else tends to have their salary, their hourly wage around $12.50, then this $22.50 is going to stand out a lot. So situation one is where everybody kind of makes the same amount except for this one person. Situation two is I still have a mean of $12.50, still interested in whether or not $22.50 is an outlier, but I got points spread out all over the place. It looks like I have a bunch of students down here on the lower end that appear to be volunteering. So maybe they're volunteering at a camp or something, so they're not making anything. And then I got other people clear up here that are making a lot of money. So in situation one, being $10 away is a big deal, but in situation two, being $10 away is not a big deal. So the determination of being an outlier, you got to worry more about, or you excuse me, this observation is $10 above the mean, but you also need to worry about the standard deviation of the data, not just that distance away from the mean. And that's what the z-score uses. So the z-score, again, is looking at the distance away from the mean, but it's relative to the standard deviation. So a little bit more about that. So distance A is the $10 here. I've just identified how far away it is from the mean. Distance B, you can think of that as the standard deviation. The standard deviation in this data is going to be quite small. And the standard deviation, okay, denoted by distance B here, is simply the average distance to the middle. Now, when our distance away from the mean is large compared to that average distance, then that's what drives whether or not I have an outlier. In this example here, the standard deviation is considerably larger, and what that implies is that distance away from the mean is not large relative to the standard deviation. So here, my distance away from the mean looks like it's going to be about 5 of those standard deviations away, 5 or 6. If I take 5 or 6 of these red arrows and line them up to one another, I'm going to match the length of the green arrow, which is the distance away from the mean. Or this distance away from the mean looks like it's about 6 times larger than the average distance. That's what the z-score was measuring. Here it looks like the distance away from the mean is just a little bit larger, maybe 1.1 or 1.2 larger than the red. The green arrow is about 1.1 or 1.2 times larger than the red arrow. And that is exactly what the z-score is measuring. It's looking at the distance from the mean for that observation relative to the standard deviations. How do I get those in JUMP? Oh, excuse me. The outlier rule. So how do I actually use the outlier rule? Well, if my z-score is below -2 or above 2, then I'm considered, I have potential outliers, is the language we usually use there. So what this would mean is that the distance to the mean for those data points are more than 2 times bigger than the standard deviation, or the average distance to the mean. So if I'm below -2 or above 2 here, then I'm going to be a potential outlier. If I'm below 3 or above 3, then I'm going to definitely be an outlier. Now this 1, 2, 3 rule is often referred to as the empirical rule. And the empirical rule is so common that it has its own wiki page here. So there's more information provided there about the 1, 2, 3 rule, or what wiki calls the 68, 95, 99.7 rule, which they're just referring to the coverage rates here. So most of the data should sit within 2 standard deviations of the mean. That's what this is saying. How do I get these inside of JUMP? Inside of JUMP, what I would need to do from my drop-down menu is just say Save and then Standardized here. Save and then Standardized. And what actually happens is the z-scores, okay, are dumped back onto the course website. Are dumped back onto your spreadsheet. That'd be cool if they were dumped onto the course website. So inside of JUMP, when I ask for the standardized values, they actually get dumped out here on the spreadsheet. So let me go into JUMP here and show you that real quickly. So from my red drop-down menu, oops, sorry about that. Analyze distribution, I'm looking at percent uninsured. Again, this is for Texas. Notice how many columns I got in my spreadsheet here. I'm going to go from Save, Standardized, and I get that new column over there. How is this value computed right here? So how is the standardized value for Crane County, Texas, how is that computed? All I need to do there is take the value for that county, which is 20.2, I grab a calculator here, I can show you that. Take the value, which is 20.2, minus the average, which is 21.2. So I have -1. So again, what that's telling me is that Crane County, Texas, the percent uninsured is about 1% lower than average. But I need to express that in terms of the standard deviation. So I need to divide that quantity by 4.04. And that's where that -0.24 is coming from here. So what that tells me is that this county actually has a standard deviation, this county's uninsured rate is actually pretty close to the middle. I'm next going to sort these by these standardized values. So table sort by those standardized values. I get a new table here. Anything above 3 is going to definitely be an outlier. And as we saw earlier in Handout, or in Part C, Gaines County, Texas was an outlier. In fact, all of these are going to be outliers here. If we go all the way down to 2, it's going to identify those 8 as being outliers. The box plots identified the top 5 here. So you notice that there's a pretty good sized jump from this z-score down to this one. So the box plots said that these 3 right here were not outliers, but these 5 were. Let me zoom in on that and just show you that. The box plots identified 5 outliers on the upper end, those 5 right there. They did not identify, the box plots did not identify those 3 there. And you can see that those z-scores are pretty close to 2. So these are potential outliers here. And I would definitely say that these 5 here are outliers. The z-scores are bigger than 2.29. And those are the same 5 that I identified with the box plots. If I go down on the other end, really low z-scores now, these are going to be z-scores on the lower end. Again, the box plots identified 1 there. The z-score approach is going to identify these additional 3 because they are less than -2. So these here would be, this one would probably be I would identify Denton County, Texas as a potential outlier because it's pretty close to that -2. But these others I would say are outliers. So that list is obtained here. And I just indicated whether or not the box plots identified those as well. So you're not going to get the same answer based on the box plot approach and also the standardized z-score approach. And we shouldn't. I mean, the standardized z-scores are using the mean and standard deviation. Box plots are using that lower and upper whisker, which involves the IQR. Some final thoughts about z-scores and outliers. People sometimes simply want to delete or remove outliers from an analysis. However, this is not always a good idea. So if I purposely exclude these counties, then I'm going to be biasing my outcomes or my analyses, especially if I take out those high ones. If I take these high ones out, it's going to depress, or it's going to lower the average unemployed rate or uninsured rate, It's going to make Texas look better. Or likewise, if I take out the outliers on the lower side, it's going to increase the average a little bit. So you need to carefully consider whether or not the outliers are going to be removed. My thought on this is maybe we should, if we have lots of outliers, then maybe we should be using a summary measure that is robust against those. Something like a median. Or go back to Part B and use that median absolute deviation. Those are going to be more robust against outliers because they do not use the mean and standard deviation. Okay, that does it for Part D of Handout number 9. Thank you.